So, very good afternoon to all of you. So Ramya has very clearly mentioned about the importance of this particular the webinar, which is planned for 3 hours duration. So, this is targeted for student community who are at the graduation level, who have experience with the software development. So, this webinar is basically towards the secure software development, especially security by design thinking. So you will understand actually what exactly is meant by security by design thinking and the importance of this particular subject itself. Okay. So there are various sessions planned. I think 3 sessions are planned. I'll be taking almost 1 hour duration. So we'll be talking about cyber threat landscape and the need for secure SDLC. Now, when we talk about the cyber security, there are many things. So, some people may say, okay, this is connected to some ethical hacking. There can be something connected to web security. It is connected with the what is it, hardening the operating system or firewalls. So, like that, we have different the security topics are there, right? Now, in today's this session or in this webinar, our goal is whatever is the threat scenario or threat landscape which is connected with the software development, okay, and how we need to take care of such the threat scenario in our security sorry software development life cycle and other things. That is the focus of this. Okay, so I'll be initially talking briefly about the what is it the threat scenario in information systems. Then we will be simple cybersecurity concepts we'll try to understand. And especially since this is connected to the software development and threat scenario, so I will briefly talk about the role of vulnerabilities in security breaches and other things, and the need for software security and secure software development. So from the software development perspective, how we need to embed the security when we are designing the software in our SDLC, that is the focus. But prior to that, why we need to incorporate security is something which we need to understand. Because see, if you are clear with why I need to solve the problem, then it is half done. The all like we can say that it is the half solution is done. So in similar lines, why first of all you need to have a security at the software? What is that the problem which we are trying to address, that we need to look at it. So at the end of this 1 hour, you'll be able to understand the threat scenario in information systems, and then the various security concepts, and then role of vulnerabilities in security breaches, and finally the need for software security and secure software development. Okay, so this is something which is very important irrespective of the branch in your graduation. So one very important thing is most of the people want to be in the software development. So when we want to be in the software development, want to have a career in that particular domain, then definitely we need to have a strong foundations in even writing the secure software. So this is relevant to all of us, and this is something which is very critical in the present scenario. Now, this slide is just to tell you about the evolution of information systems. Maybe you all would not have been there. You would have seen the mobile computing era or enterprise computing era onwards. Like, but see, you've seen that big high performance computing missions occupying a big building kind of things is something mainframes. Okay, so that is the way the initial information evolution happened. Then later, so we have the personal computers, then each one is able to work with a separate computer having the keyboard and monitor kind of environment in which the systems have evolved. After that, these computers are all connected through the computer networks with the TCP/IP default, the de facto stack, and then the various client server applications are developed. Like, sorry, now you talk about HTTPS, between the browser web server communication, telnet, FTP, SMTP, like that. We have built the client server model on top of this particular computer networks, having the de facto the TCP/IP protocol stack. So with that, along with our personal resources which are existing in our local personal computer, we are able to access the resources available somewhere. Now, like see, with the client server model only, you are able to connect to your email server and check it out. So you just go to the browser, you connect your Gmail. So what happened? The server, Gmail server, is located somewhere. It can be anywhere in the world. You just give the URL, and then try to connect to that and access the service. So computer networks have helped us, and the World Wide Web and client server model helped us to access the resources and services across the globe through the network. So this is the kind of evolution. Then we talked about enterprise computing. So now at the enterprise level, see now, there are our own organizations. At the enterprise level itself, we are using IT for the various operations like HR packages, financial packages, okay, like that, internal to the organization. For all the various activities related to the enterprise management, we depend on the various IT management. Further, we moved into the mobile computing era, so where we moved into the handheld devices. Okay, so it's almost a small computers in our hand. Initially, these computers, small computers or mobiles, were the feature phones, which are meant only for making a phone call and looking for SMS and other things like that. So you would have seen the Nokia phones and all. But gradually, now we are talking about the smartphones, which are very, very sophisticated, which are almost equivalent to a computer, personal computer. So where you are able to install new applications, all kind of things, whatever you are able to do on the personal computer, now you are able to do that. And gradually, we started accessing the software as a service, infrastructure as a service. Instead of we owning our own infrastructure, we are trying to access based on the requirement, in a service mode, from the people who are enabled that. So we know the cloud computing, Amazon cloud, Google cloud, like that. So various things are installed. This is another model. Okay, so based on the need, you try to access is as a service. So we also have a distributed systems, okay, peer-to-peer networks, which are very, very popular in the blockchain and other things like that. So that is one thing. And in the we are also very much using this IoT and edge computing kind of thing. Now the cyber physical systems, actually, like you talk about. So what is happening is these cyber physical systems are the ones which are sensing the physical world, and which is helping us to carry out the various day-to-day activities. Okay, the various physical parameters and other things from our the environment are sensed, and through which we try to carry out that. Okay, so and edge computing, rather than having a cloud, we have the edge computing, which is very, very close to the IoT nodes, where you process the information and derive some inferences out of it. And very recently, we talk about autonomic computing, okay, self-managed and self-healing kind of systems. And with the wide the adoption of the artificial intelligence and machine learning, this is something which is very much becoming to address various activities in our day-to-day life. We talk about autonomous tractors, autonomous cars, like that. You talk about any, so they are all self-driven or kind of thing. No, why I'm trying to highlight this is, this is a kind of evolution happened in the last 4 to 5 decades, or maybe more than six. We can say 6 decades or so. Okay. Now this is that. See what happened in the evolution. See, you are. It's a more convenience to the end user, and you want to efficiently utilize the resources. Or sometimes what happened is, with the reduced in the cost of silicon and other things, so we are able to afford the more the compute and have our own personal resources and all, for convenience, improving the performance and other things like that. Okay. Now, irrespective of the kind of information system across all the things, okay. See now, if you think about, visualize about current systems, they are something like this. Our environment. So maybe you just visualize about the your enterprise or your personal computer environment or anything like that. So we have a combination. We'll have workstations, we have servers, we have laptops, mobile devices. Mobiles are also small computers. Okay, printer has got a firmware with some kind of embedded code inside in that. We have the switches, we have the Wi-Fi routers, all are connected through the internet, whether it is wired or wireless protocols, we are connected to the internet. From there, we are connected to the external world. Now, this is the kind of complex environment in which we are currently working. And every device has got a software, and it is able to carry out some task. And see, when there is some convenience to the end user, the same convenience exists even for the attacker or adversary to carry out some malicious activities. Okay. Now, if you see this slide, the left hand side, you can see that the list of various threat scenarios in which we are currently living in our IT systems. There are viruses, worms, ransomware, botnets, phishing attacks, insider threats in the sense from the known people, the people inside our environment, they are themselves trying to create some threats, distributed denial of service, drive-by download attacks, SQL injection, exploit kits, cryptojacking, or malicious crypto mining with the cryptocurrencies and all, where there is a need to solve a puzzle to add a block into the crypto networks, or generate some bitcoins. So they require a lot of compute to solve the puzzle. So they try to use all innocent machines without their knowledge. They try to insert an agent and use the compute cycles. These are the shadow IT threats. Without the knowledge of the IT team in the organization, they'll connect to the external world and try to have some kind of backdoors kind of thing. And advanced persistent threats are some advanced threats where, without the knowledge of the environment or our in our systems, some the threat agent can come and reside and carry out the malicious activities. And there are 0 days. Like what I'm trying to highlight is, as we have evolved over the period with our information systems, which is trying to give a lot of convenience to the end user. Okay, so now instead of sitting at the desktops, carrying out the activity through a mobile is always better. On the move, everywhere you are able to carry out many things. But at the same time, the kind of convenience whatever we have, end user have, the same convenience exists. All these advanced technologies are being used by the even adversary or hacker to carry out malicious activity. Now these are all the malicious activities which exist in our systems. Now let me see. Now you might be thinking why she's trying to highlight all these kind of things. Our goal is to talk about software security and secure SDLC. But we will be able to appreciate that secure SDLC. We are very clear how these threats are connected with that particular software development. So that's where I'm trying to bridge these particular two sections through this initial slides. Now let us try to understand about significant security breaches. Some things. Okay. So this is just a slide. This and next slide you'll understand. There are viruses, worms. We try to call all these malware with the different names. Okay, there is the specific behavior. Because of this, it is called as a worm. There is a specific behavior. Because of that, it is called as ransomware. So when I say worm is a malware which is self-propagating. It does not require any host, like a device or an application through which it will try to go to the other machine. It can try to open the network connection, and through the network it will try to propagate to the other machines. So one of the worm which was generated in the year 2001 from Chinese. So what it has done is, I'll tell you the details about the vulnerabilities and all. What it has done is, see, now you must be aware, in order to host a web application, any web service, you need to have Apache, Tomcat, or something like that. Components we try to host it. On top of it, you will try to host the web application. Similarly, on a Windows environment, we have IIS web server on which the various web portals and all are hosted. Now, what this code red worm has done is, it has exploited a buffer overflow vulnerability in the IIS web server. Okay, the on Windows, the machine. It has exploited a specific vulnerability. I'll talk about vulnerabilities later. It has exploited some kind of loophole in the IIS web server, and then it has penetrated into the IIS web server, and it has defaced those web applications which are websites which are hosted on that particular thing. Defaced or launched denial of service, like that. Now, in this case, if you notice, there are various red spots on the world map, right? These are the red spots are the places across the globe. Okay, at a specific time, July 19th, 1 hour 5 minutes kind of thing in 21. So these are the red spots are the places where this code red worm has infected the all the IIS web servers which are hosted on the Windows machines, where their portals and other things are hosted, defacing them and all it has done. And after 19 hours, this kind of spread happened. Okay, so what it has done, worm, one of the unique property of the worm is it can penetrate over the network. So it has penetrated, and the time is 21:5. So 19 hours and another 10 minutes time, it has spread like this. So that means across the globe, whatever the machines which are hosted on the IIS web server, the various web applications and web portals, they are all defaced, or some kind of the damage is caused to them by exploiting a vulnerability in that. So this is the kind of impact the malware has done it. Similarly, whether you are aware or not, in the year 2017, we have noticed in the early morning, we have seen in the newspapers everywhere on the internet that WannaCry ransomware has created havoc. It has infected the various Windows, the computers, encrypted the files on the hard disk. So ransomware is a type of malware. What it does is, it will, once it penetrates into a system, it will try to encrypt all the files on the hard disk and demands for some ransom. Okay, so if you make that particular ransom amount in terms of Bitcoin and other things like that, then it will try to give the keys to open the encrypted files. So that is how it has infected. So across the globe, the various post offices, police stations, hospitals, all these things, may measure various departments, they are all infected with this particular ransomware, and they are not able to access their own files. Okay, so this is the kind of another malware which can happen. And for the IoT devices, I think every one of us have seen the CC cameras everywhere. Okay, at the same time, IoT, the Wi-Fi routers in our own home and offices everywhere. Okay, these are all IoT devices. Okay, so now what this kind of Mirai malware has done is that, now many times what happens is, if you notice, these devices will have some kind of default password. Okay, so generally what happen, once it comes to your environment, then it is your responsibility that to log in through the default, and then make the configurations, everything, and you change the password, right? But many times what happened is, most of the devices, they are still continuing with the default factory enabled passwords. I think the particular vendor, he tries to use some 30 default passwords across the various devices. Once you have access to all the 30 default passwords, what the Mirai malware has done is, it used to sit on one of the Wi-Fi router, used to scan all other routers over the network and try with those default passwords. Many times people have not changed the default password, so it is able to log in into that. Once it is able to get the access to the access to that particular Wi-Fi router and all. So whoever have unmuted, please mute themselves. Please mute it. At the end, we can have an interactive session where you can ask the questions. Because once you do this, then it is going to disturb everyone. Okay, so once it is able to get access to this particular thing, then what happens is, this botnet works with the command and control server and all. So it will contact reports. There is a report server. It will say, bot will say, these are all the Wi-Fi routers and CC cameras which are vulnerable. They are continuing with the default password. So then it will have a list of that. After that, what the Mirai bot web server will do is that it will try to install a bot again onto these missions. And now what happened, once the bot is installed, all those machines are infected with this particular Mirai malware. Okay, now command and control server will give instructions to all these routers to act and cause some kind of damage. So launch a DDoS attack on a server or something like that. It will give some malicious instructions to cause the damage. So this is the power of this. So now this, if you look at these kind of devices, they are all in lakhs or millions of the devices. So if you see that all these millions of devices are going to attack something, the damage is too huge. Okay, so why I'm trying to highlight is, these kind of things happen to our IT systems. So we might have developed the applications, we would have hosted and using on a day-to-day purpose. But the problem is, so these kind of things can try to cause damage and carry out the various malicious or undesired behavior. Generally, we categorize the malicious behavior in three categories. Okay. So one is the threat against the confidentiality. What is this threat against the confidentiality is that these malicious entities, they try to steal information. Okay, see, generally if you look at it, when you have a application, when you have a specific application, what happens is that there are some authorized entities who need to access that application and the data connected to that. So you write that what is the role of the person. So depending on the various features of that particular application, which features are accessed by which user, like that, you design an application. As per that, you expect that system to work. But it might happen, because of some kind of malicious intention or having some vulnerabilities, it may happen the information might be stolen. Okay, so without the knowledge of, or without the authorized people, someone unauthorized people are trying to access this information. Can be related to the corporate secrets like source code, financial details, trade secrets, like that. Or it can be passwords which are sent over the wire, or pin numbers, credit cards, like that. So any unauthorized person may try to steal this kind of things. This is one of the malicious behavior. Another malicious behavior is that unauthorized entity might be able to modify the information or functionality. Okay, like I was telling about even cryptojacking. what happens is that the malicious agent get installed in our endpoint, which will try to consume your CPU cycles to solve the puzzle. So without our knowledge, it can be a spyware or botnet client, or it can be a Bitcoin agent, or it can be anything. So unauthorized software without my knowledge is trying to get installed in my endpoint. So and then sometimes it may try to get installed without the knowledge of the authorized entity, or maybe destroying the records, okay, logs and other things like that. So these kind of things happen. And the third one is denying access. Okay, it is threat against the availability. It is the threat against the availability. So generally, what happen? Denying access. Sometimes what happen is like through the denial of service attack kind of thing. So suppose you want to connect to an online website to purchase some products, or maybe carry out the online banking service or any kind of service. Suddenly you notice that though you are the authorized entity, you are not able to connect and complete the service, because the malicious entities might have launched denial of service on that particular service, and the legitimate people are not able to access. So though all these IT systems and lot of sophistication happened, these kind of malicious things can be launched by the adversary in our systems. So what is expected, what is all about cybersecurity, whatever we talk about cybersecurity, basically is the ultimate goal is focus. Generally when you talk about these computer applications or any kind of thing, desktop or online applications, each application is designed with a specific behavior in our mind, right? Browser, what it does a specific task. Word processor, MS Word will do something. Online banking, there is a clear the requirements and specifications, accordingly the system will perform, right? Online shopping, like that. But this way we have designed our systems, right? Maybe a office package, or maybe SAP ERP package, like that, anything you talk about. Okay, employee payroll system, or finance package, or HR package. Okay, everything has a specific goal to be carried out in a online or in a automation mode. But what the adversary or hackers will do, that their main aim is to cause undesired or malicious behavior. Whatever IT systems which we have built, their goal is to carry out undesired or malicious behavior. Okay, so in order to overcome this kind of malicious or undesired behavior, what we do as part of the cybersecurity is that we try to provide various mechanisms, tools, and other things, so that adversary don't penetrate and carry out these malicious activities. Okay, so we use a lot of collection of mechanisms, tools to protect data and functions, and to prevent hackers and adversary to penetrate into our systems. We include a lot of cryptographic algorithms, firewall, intrusion detection systems, antiviruses, okay, threat intelligence, like that. The various solutions we deployed various levels, so that we enable cybersecurity to prevent the unauthorized or undesired the behavior in our systems. Okay, and it's not only technologies. We depend on various things, like it is a holistic approach. We should have general awareness. We should have some kind of skilling required. We should have some kind of governance frameworks. Okay, all these best practices, everything we need to include along with the technologies to address the cybersecurity problem. Okay, so just up to this point, what I try to highlight is what exactly is meant by cybersecurity, which I try to highlight. And this, you don't worry, these are kind of solutions which normally we deploy at endpoints, are the gateway. Endpoints means at the desktop level. So we talk about desktop or mobile endpoint. Okay, even IoT device is also an endpoint. Antiviruses, signature, behavior based, heuristic based antivirus, or user behavior analytics, SOAR, anti spyware, like that. Over the period, the various solutions are developed to protect the from cyber threats at the endpoints. Similarly, gateway level also, we have gateway antivirus, intrusion detection, intrusion prevention, virtual private network, unified threat management appliance, threat intelligence, security information and event management, like that. The various solutions are deployed at the server level also. Okay, so just some understanding. Now we will try to go to the actual the problem or the topic of today's webinar. Okay, but for that, I am coming back again to this WannaCry ransomware. Just look at it. As I mentioned previously, worldwide attack happened through this particular WannaCry ransomware in May 2017. Okay, so it has targeted computers with Microsoft Windows operating system using one SMB version 1. This is a server message block version 1 vulnerability through the kind of exploit. Okay, I will talk about what is exploit and all. what I will try to highlight at this stage is there is a weakness or a bug available or a specific loophole available in this particular the protocol SMB version 1 protocol, so through which the ransomware has penetrated into the Windows environment and encrypted the files, because it does not have an authorized entry, but through vulnerability it has entered, penetrated, and injected some exploit code, malicious code, for encrypting the files and demanded ransom payments. Okay, so and so this is what happened. And later, see, you need to analyze here. I think many of the time, what happens is you keep getting some kind of messages telling that you please update Windows now, kind of thing, right? So generally, what happen? People keep postponing the update mechanism. The reason is that is not important because I am doing something now. Once if I go into the update, I am going to waste that. But one thing what we need to realize is these updates, whatever you get, are nothing but these kind of fixes which are given. Either it can be a updated, modified features, or it can be some kind of the patches to the vulnerabilities which are detected at a later point of time after the software is released. Okay, so for this particular case, if you look at it, Microsoft released the patch in March 2017 itself, and attack happened in May 2017. What does it mean? Though the patch was released for this vulnerability, SMB version 1 vulnerability, in March 2017, people are not patched them. Okay, so that means they have not patched them, and that is the reason all the machines which were still left out with the vulnerability without patching, they're all infected, and it has got a warm component. When I say ransomware, generally the thing is it will try to encrypt the files and demand some ransom amount, and it has got multiple functionalities of a malware, like it is a warm component, it is self propagating. So over the network, after carrying out a damage on a specific mission, it is able to spread over the network and cause the further damage. That is how within no time, in a day's time, across the globe, multiple missions across various departments, across various countries, they are all infected. Okay, so WannaCry is spread through organizations who have not patched their computers, or spread through older Windows systems. So in the year 2017, if you notice, Windows XP was not supported anymore. I think 2016 or 2000 sometime, Windows stopped support for Microsoft XP, Windows XP. So when they say that they are not going to extend the support, what does it mean is they are not going to give any fixes for the newly detected vulnerabilities in that OS. What does it mean is it's always required for the end user to stop using those variants of the operating system and move to the later versions of the operating system which are supported by the particular the company. So later we had other things, Windows 2000 and so many other things which we were supposed to use. But what happened? People were still continuing with the older version. That's so that is one thing. Okay, so this is what happened. So it is very important that we will try to update the patches immediately. And another thing is, whenever the publisher of any software says that they are not going to support this particular software anymore, it is a responsibility of the end user to stop using that particular version of the operating system or any software. Okay, so here we what we understand is there is some vulnerabilities exploited by this. Now let us come back. Okay, let us try to connect to this. What exactly? We all know something about what is a bug and try to connect it with the vulnerability also. Now, whenever you try to design any software, okay, so like we have different phases, right? We have the requirements gathering phase, where we try to collect the requirements from the end user who wants this particular software to be built. We'll try to understand how exactly wants the software to behave, all that you try to capture, who all the stakeholders who are going to access it, all the details you'll take it, what is the environment it is going to work, what kind of performance required, what kind of scalability requirement, what are the safety requirements, like that you collect all the details from the particular customer and you try to design that. Okay, so after you design, then you try to implement it in a specific programming environment, and then there's a testing phase where you try to make sure that the system is behaving as per the requirements given by the end user. So we thoroughly test it in line with the requirements given to that. After some time, once it is done, then you put it in the production environment and other things like that. But one thing is, it is not possible for any software to be 100% tested. It is not possible. So generally, even the best possible companies who can invest a lot of money and with experienced people, after some time, when they have done reasonably the thorough testing, and then it is found to be robust, then they will release it. After they release it in the production environment, as there is a maintenance phase, as and when something is detected after it goes to production, which was not detected during the testing phase, immediately they'll try to give a fix, that is called a patch, and release it to communicate to all the end users. So that is a normal cycle. So it is never possible that we can say that the software is going to be 100% testing. So maintenance phase is a must for any software. And till you see, maintenance support is very important for all the end users. Only when you say that you don't want to extend any support, at that time you will indicate to the end users and then stop giving the support for fixing the bugs. Okay, that kind of thing is important. Now, generally we'll have different kinds of bugs which can functionality related in terms of features, or it can be non-functional kind of things. But see, a subset of these bugs can be vulnerabilities, or also called as vulnerabilities, if that particular bug through which you can exploit the confidentiality, integrity, and availability aspects of system. Okay, there is a bug left out, and through that bug, if you are able to steal some confidential data, or inject some spyware, the threat against integrity, or maybe able to launch some denial of service, if you are able to carry out violate any of the security policy of the system through any bug in the system, such bugs are called vulnerabilities. Okay, subset of the bugs are called you are able to exploit the security weakness through those particular flaws. So it can be a breach against confidentiality, integrity, or availability. Okay, so these are, so now when you design a software system and once you put in the production, it is possible that the whatever bugs which are detected at a later point of time, a subset of those bugs might be the vulnerabilities, okay, through which the security can be compromised. So now just look at this particular diagram where we am trying to highlight. Assume that just we'll go back. Okay. Uh, Hope you are able to listen. There is no issue. Just respond to this. Is it okay?
Yes, ma'am.
Yes. Can you show
Okay, ma.
some
Right. Thank you.
some
Thank you.
practical
Yeah.
things?
Okay.
We
So
have a question
just look
from
at this.
participant.
Yeah. Can
Yes,
we take it
Yuvraj.
up at the end?
Did, yes, ma'am. Sure.
Yeah, we'll take it up. Let him note down. We will come back to the questions. Okay. Now, trust boundaries, and see now, as I'll assume that you are a web developer. Okay, this inner the this kind of rectangular area is a web application which is hosted on the network. Okay, now generally what you do when your web applications develop, depending on the role of the person who is going to access, you will enable the login credentials. Okay, and the legitimate users who can connect to that, they will log in into that, and they will access the different functionalities. Okay, so these are trust boundary. Unless you are going to prove yourself by giving the credentials like password and other things, you will not get enter into the trusted zone. This is a trusted zone. Okay, the entire thing is untrusted. So you have to cross this trust boundary, you need to give your credentials, whether it is password or OTP or whatever it is the mode, you have to provide the details, and then you are going to access that. Okay, that is why any application, just think about it, whatever you developed or you used it on the internet, the system works like that. But if you look at it on the other side, I'm talking about adversary or a crook whose the intentions are to carry out malicious thing. What he will do is that he don't have login details or he don't have the main door entrance, but he's looking for some vulnerabilities which are left out in the systems. He look for some kind of bugs which are left out in the system, which can be exploited and breach the confidentiality, integrity, or availability aspects of software. That is how the adversaries will work. Adversaries will try to look for vulnerabilities in the software. They will try to see whether any of these bugs exist in this particular direction, look for them, and then through that they will try to inject some malicious code or scripts, exploit these vulnerabilities, and then launch the attacks. So that is how generally these kind of things will happen. Okay, even in the production system, we might be thinking we have done a thorough testing, everything. But the problem is when you say thorough testing, it is never 100%. Even you would have seen the best companies like Google, Adobe, or Microsoft, or who can invest large amount of money and then with a rich experience. Everyone have got their own cycle. The once it goes into the production, there is a maintenance phase. Whenever a new bug or vulnerability is detected, there is a cycle, patch, development, communicate, install, all that will be there. Okay, so this kind of bad things can happen to our systems which are hosted. Okay, that is why generally whenever a vulnerability is discovered, uh, develop the patch will be developed. Okay, and alert or communication given to the end user to install that patch. Okay, which we are all aware of. Okay, so the one thing what I want to highlight is we have tried to understood our information systems. Then we have seen lot of things like viruses, worms, so many things are there. And then we try to understand like what exactly like kind of things done by the malicious or kind of thing. Then we see that they generally violate the or compromises confidentiality, integrity, availability. For that reason, through cyber security solutions, we want to make sure that the malicious behavior don't come in our systems or block or whatever it is, detect and other things like that. Later we try to see that vulnerabilities in the software is one of the section of the things to which can be exploited, and then the systems can be targeted and malicious thing can happen, where we try to discuss about the WannaCry example. Okay, with the WannaCry we try to see that what happens in this particular case, right? Exploited vulnerability, and then it has caused the encrypted file. See, it is what happened, non-availability. It's a kind of denial of service. My own files I am not able to access through this particular thing. So these kind of things can be done by that. Okay, and how these vulnerabilities are there in our system, who is created? When we build the software, there are some bugs left out which are not detected during the testing phase, and this becomes channels for the adversary to enter and then try to launch the attacks. So that's why in the post production, once it goes to production, the maintenance phase, this cycle continues for every software. Okay, now there is something you would have heard about the zero-day attack also. Okay, so zero-day attack normally is the one basically. See, again there are some things like known attacks and and unknown vulnerabilities. Known vulnerabilities in the sense, generally when you host, put a system in the production environment, as and when a new vulnerability is detected, immediately the patch is developed and then installed. Okay, so there is something like responsible disclosure of vulnerabilities also. So people, what happen, the responsible manner, they will disclose telling that there is a vulnerability in your system like that. So that helps to fix the things. But some of the malicious intention people, what they do, they don't disclose the vulnerability. Okay, to the producer of the software, okay, publisher of the software, they don't disclose the vulnerabilities. And whenever they found a vulnerability, through that they will try to attack the system without telling to the publisher of the software. Such attacks are called zero-day attack. That means the developers don't have any idea of what the vulnerability, and they have 0 days to address and patch they don't have any time, because already the adversary has detected some new unknown vulnerability in the system and they have attacked the system. These are called zero-day attacks. Okay, so the 0 days exploits are used or shared by attackers to launch attacks before the developer of the targeted software knows about the vulnerability. So this is again another problem. Now the question is, from where these vulnerabilities are coming? Okay, so we are telling these are the bugs in the systems. Okay, there are various bugs which can be left by the developer of the softwares. Okay, it can be buffer overflow vulnerabilities, integer overflow vulnerabilities, invalidated input. Okay, now whenever you call a function, you have passed some arguments to that function. Within that function, whether you are validating the inputs properly or not, when you are concurrent programs, when you write, okay, at that point of time with the multi-threaded applications and all, are we trying to address the race conditions properly with the semaphores, mutex and all? Otherwise, you end up with some vulnerabilities, access control problems. Okay, weaknesses in authentication, key lengths like that. There are plenty of vulnerabilities which can exist in our the softwares which you have developed. Okay, which become the channels through which these kind of attacks happen. So now this is also, you might be thinking very, very simple. In C and C++, there is no automatic bound checking on the buffer. Like for example, when you write a program, simple thing code I'm trying to talk about, there is a buffer of length 10. Okay, so generally when you define a buffer of size 10 of integer type, what does it mean? You are storing some 10 integers, that much size buffer you allocated. Now, and how do you refer to the locations 0 to 9? Buffer of 0 to buffer of 9. So that is a 10 indices to refer to the 10 elements of this buffer which you allocated. But it might happen if you write a code like this, buffer of 20th index is 15, it is going to accept. The reason is, see, it has no bound checking in the C or C++. Clear? Whereas when the same thing, if you try to put it in the Java language, it will say array index out of bound exception. At runtime, it is able to throw. Okay, so it is out of bounds. Whatever array you allocated, you are outside the indices of that particular thing, like that. So in many cases, when I said code red worm has exploited this kind of vulnerability. Okay, buffer overflow vulnerability was exploited by the code red worm, which has spread through the IS web server. What it has done, see now what happened if the character buffer is of size 10, and into that buffer if I am trying to put a string, okay, and the string when it will stop accepting the data, if it is a white space character, okay, or a tab or a blank or whatever it is, okay, maybe the new line character, till that point of time it will take all the characters even if the size is more than 10. Okay, so that's how what the attacker adversary will do is they will from outside they will monitor whenever you are taking input, whenever this particular program is taking input, whether the bound checking is done or not. If the bound checking is not done, they will try to inject through this particular buffers the malicious codes, and then it will try to override the stack and then try to launch the attack. Okay, so this one of, see, the stack, if you look at the stack actually activation records of the various functions which are stored at the execution time. See, buffer is of this size, 10 locations. Suppose if you are putting more data, it will try to overwrite into stack frame pointer. There is a code, automatic code checking is not done. Okay,
Ma'am, we are unable to see your screen.
is it so? What
Yes,
happened?
ma'am.
Just 1 minute. 1 minute. Is it now itself or?
Just few seconds ago.
Okay, okay, right, right.
Just now.
Okay, 1 minute. Is it fine?
Yes, ma'am.
Okay,
We're
right?
able to see. Yeah.
So what I mean is, in the like in this case, what happened is, like see, user has allocated only character buffer of 10 on the stack, okay, as part of the function. But he is trying to, there is a limitation in this. He is not validating whether you are restricting to the character buffer of 10 locations or not. If you are not able to carry out the bound checking in the program, then whatever data which is trying to type in the buffer, it will try to go and try to overwrite into the stack frame pointer and return address, like that. So that is how manipulations can be done by the attacker, and then he can try to inject some malicious code to carry out some damage. So if you look at it, buffer overflow is a memory usage vulnerability, and it is the most common form of security vulnerability. Okay, it is the most common form of either, see, code red worm, and even present day many of the things still happen even with the buffer overflow if you are writing the code at the low level. Whereas Java high level languages, Java and all, they have taken care by giving a runtime exception in case if you are trying to cross the buffer you are allocated. Okay, so buffer overflow occurs anytime the program writes more information to the buffer than the space it has allocated in the memory. So well-known internet worms, code red, slapper, slammer, they use buffer overflow attacks to propagate and execute the malicious payloads. Okay, payloads is nothing but the malicious code, okay, through which it is going to cause the damage. Another very important thing, especially when you are writing the GUI programs with the backend database and all, is like this. So now, whenever you develop the web applications and trying to put some queries to the database and all, generally in the web form, we have the various text fields and all, through which you try to submit the data. Okay, sometimes you want to verify whether password is correct or not, or something like that. The data will be pulled, and internally that data will be given to the SQL query. This SQL query will be applied to the database, and then accordingly the response will come. It may happen that, see now, generally what happen, select fields from field where field is equal to something. Suppose whatever is highlighted here, anything or x of, if this is typed in one of the text field, For example, if this is typed in one of the text field by the end user. Two, so what happened in this case? There is a or condition. I just need to give field value as a password. Suppose admin 123, whatever is the password, I just need to give the password here. Field values, select fields from table where field is so and so, where match is existing. Now, what happens is in this case, field is anything, or I don't know the right information to pull the data because I am the adversary, but I want to penetrate into the system. What I did, anything, some junk I will give, but I am putting an or condition here, or x is equal to x. If you look at it, the right hand side is always true, irrespective of whatever is anything, field is matching with anything or not, the outcome of this is always one, because x is equal to x is one, or condition, if any one is one, automatically the entire thing is one. So that is how, though I don't have the value, field value with me, but still I'm able to pull the data from this particular thing. Okay, that's why we tell that whatever the data which you give to the web forms, to the middleware code, it has to validate that particular thing. Otherwise you need to have prepared statements so that you can avoid this kind of SQL injection kind of thing. Okay, now the lot of the malicious things can happen through this. The adversary could log into the application as another user, sometimes even as an administrator. The adversary can view private information belonging to other users. They can change the application configuration, they can modify the database tables or delete the tables. They can take the control of the entire database. Okay, so if you had put the proper validations for the data whatever is received through the web form, this kind of thing would not have happened. And similarly, many times when you write the code, you put the sensitive, the hard coded strings like this. Now in the binary, the strings are visible. Okay, so when you see that, these can give some clues for the malicious entities to penetrate into our systems. Okay, so that's why what we say is that never hard code sensitive information. You pull that from a file rather than, and the file will have restricted privileges. Who can access this application only can access in this mode, like that. Okay, now we will try to avoid, even if you try to analyze the binary, you will not be able to get the strings which are the IP addresses. These kind of things are very, very important. Now the question is, why we write the bad code? So most of the time when you try to learn the programming, we are more interested in the technical things. Okay, we are more interested in the what are the various concepts of that particular language. Then we try to look at the syntax of that particular thing, and immediately you start building the logic in the using that programming language. But many times we are not learning about, what if I use these kind of things, what kind of the impact vulnerabilities I'm trying to leave in the programs and all that. Normally we don't learn when we are learning the programming, which is very, very important. Another thing is, see, if I give the same algorithm for two different people, no, okay, or if generally, like suppose if you have a limited work is given, then definitely can do a good job with thorough validations, with a lot of comments and all. But what happens if we try to put too many things on a person, ask them to sit for 12 hours, 15 hours coding and all. Many times they try to skip the validations and other things. Okay, and two different people also, if you do the same work, two different approach will be different. Okay, psychological aspects and all will vary, and that is impact. And real world factors is, many companies want to release their the software first. Okay, they want to go to the market first, so with that they try to compromise in the testing and other things, so that these vulnerabilities will be left out. Okay, so now you would have understood what that there is something called as a the bugs which we are trying to leave. It can be some kind of what is that, array bound checking can be one reason, or something like the data which you are giving through the web forms and all text fields and other things, text areas, whatever. So once you pull inside your middleware the application, there it should validate the data properly before giving it to the things and all. Otherwise, that can be a channel through the adversary can try to penetrate into our systems. So now these are, who has done that, these are all actually left out by the developers. Okay, now the question is, what is the need for software security? The reason is, see, firewalls, intrusion detection, prevention, malware detection solution, threat intelligence systems, whatever we talked about in the previous slide, which we deployed at the endpoints as well as at the gateway, they all are basically reactive in nature. That means if something is getting penetrated, they try to stop it, but they don't prevent the vulnerabilities which exist in our the code whatever is written. Okay, they try to block. If something is penetrating, they try to block it, but as such they don't prevent the vulnerabilities which are left out in the software. So there is a need for software security. Okay, so what is that? In order to do this particular thing is, we need to see, the people might be thinking, see, now there is something called penetration testing. After I develop the software, before I put in the production, I have something called as a penetration testing, VAPT I do on that, so which is going to detect all this, but it is not the right approach. VAPT alone will not be able to do everything. We need to focus to minimize the introduction of the various the vulnerabilities by looking at from the requirements phase itself. Okay, design flaws and whatever bugs during the complete software development life cycle, we should follow the security aspects. Okay, so what is the risk involved in this particular application, that you start gathering from the requirements phase itself. Okay, so you should follow the risk management approach. It is not just eliminating vulnerabilities through a VAPT. VAPT is only one entity in the entire mitigation process. Okay, so what is required is across SDLC, starting from requirements gathering till the end of the, we need to follow the security to be implemented at every phase. Okay, now let us see this particular slide. Just we'll go back. So here, if you look at it, just I think most of you might have known about this secure SDLC, sorry, SDLC generally. So first step, whenever you want to design any software, you collect the requirements and the use cases, you build the use case diagrams and other things like that. Now, then you go for the designing. Once the design and all is done, you implement in a particular programming language, you test it, okay, thorough testing, and you go for the deployment. Further maintenance and all will exist. Now, along with these things, you can see the green color and other things which are mentioned here. These are important. Whenever you are gathering the requirements of the system which you are trying to build, you also need to think like an attacker and see that how my system can be misused in the production environment, how my system can be abused in the production environment. Those abuse cases also I need to look at it. Okay, what is the attack surface of my application? Who all can try to access this? How they can try to cause the damage? So from these abuse cases, what we do is that we'll try to understand the attack surface and model the threat. Okay, and identify the security requirements. Now, if you analyze, now whenever you connect to a online shopping site or any kind of thing, online banking, from browser, HTTPS is enabled, right? So HTTPS enabled because from browser up to the remote server, the secure channel is created. Why it is created? Because the people who have developed that application, they felt that if it is sent in the plain text, the adversary can try to look at your password details, they may look at the pin numbers, they may look at credit card details, like that. So that is the abuse case. That is how the people can abuse the system. So we identified secure channel from browser to the web server is a requirement. So that is how risk analysis, what is the risk for of my application in the production environment, that I will analyze while gathering the requirements itself. From that I will derive security requirements. Once security requirements are derived, I will design the security. By secure means I use various encryption techniques, virtual private network, SSL. I will try to design and then implement. After implementing, again, code level vulnerabilities, static code. Okay, code level, whether I used it, suppose for example, I would have used arrays, but there is a problem, I have not written the validation, something like that. All that code level, static code analysis, runtime code analysis, all that we try to use, and all of follow some kind of coding guidelines. And finally we try to carry out security testing also. So what does it mean? Whatever the abuse cases which you anticipated and you identified in the this thing, I have to test again my system against those abuse cases and see how robust it is to protect from them. Once I do all that, then I will try to give to a third party to carry out VAPT for a safe to host certificate. Now I have done everything, but still I want a third party to give a green signal to test that yes, you have done a good job and now it is free from known vulnerabilities, you can go for production deployment. Then pen testing will happen, and then you go to the deployment. So but after you go to the deployment also, it is possible that some kind of vulnerabilities and all can be detected, as I mentioned, and the patch management and all should exist. Okay, that is how, see, we are moving security measures. If you look at the evolution over the period, initially we thought patch management is okay, then penetration testing is okay, then code analysis okay. Now we are talking about security in the entire software development life cycle, starting from the requirements and use case. That is how it is a left shift happen, shift left happen. Okay, in this security as well as the privacy also, privacy aspects also, if that is a requirement, we need to think about both the things in the SDLC phase. This all which is very very important. Now tell me, is it like only cybersecurity is something which is a specialized field, and whoever want to learn, only they need to learn the security SDLC? Not like that. So secure SDLC is something which is very very important now. It is no more a specialized domain. It is the requirement of every software developer to follow security by design by following this particular thing. It is very important. You should think like an attacker, be at the requirements phase itself. So after my system goes into the production, how the adversary can exploit that, I should visualize while requirements gathering for my system itself. At that time itself, the misuse case or abuse case also should be collected. That helps me to design the security and then thoroughly test and make it robust so that you can try to protect from all those kind of things. Okay. Now this is something which we are trying to look. So there are various architectural principles, lot of things in depth, principle of least privilege, many things are there at the architectural level, design level, security by design, default also. When you have a default mode any software, it should not leak any inputs. That's also the at the deployment phase, communications. So it is very important. So Microsoft follows this trustworthy computing security development life cycle, where security by design, security by default, security in the deployment, and security post deployment, like effectively communicating the alerts and patches. All these things are part of their software development process. Okay, these are architectural principles which will try to make your the security robust in your systems. Okay, so like that, all these things becomes very very important. See, one thing what we need to look at it, when we are developing the software, what is our goal? We should not leave the vulnerabilities, because vulnerabilities become the channels for the adversary to penetrate and launch various attacks, or even malware spreads through them, like we have seen the WannaCry, code red worm, Mirai, and like that various things. So now when I see in this case, in the Mirai case, I said that Mirai spread through the default password. Even that is also a vulnerability. Okay, see, you can never continue with the default password after it is hosted in that particular environment. You should change the password immediately. That is a requirement. It can be something like the IP addresses are kept in open, or some details, even the files are exposed. Even that is also a vulnerability. All the, it can be configuration related things, or it can be a default password. It can be anything. All these things combinedly need to be made robust so that your system cannot be penetrated through the adversary. All those becomes the this thing. So very very important steps which we need to follow while designing the software so that the software is secure is that, while gathering the requirement space, first you try to identify the misuse cases, how my systems can be misused in the production. Accordingly, you try to identify what security features have to be enabled. It is not that 10 security features I am putting everywhere. Okay, not like that. Security, what features are required, again depends on the attack surface, how it can be misused, and the department in which you are. If it is a strategic agency, your security to be should be of highest level. If it is a not a general kind of thing, then you try to look at it as per the requirements of that. Like that, we need to think about all that. So then detailed threat modeling, attack surface analysis, followed architectural and design security principles. Suppose if you need only 3 permissions, you should not unnecessarily open 10 permissions, because any extra privilege is a channel which can be exploited. Follow secure coding practices, and then thorough testing of the code, static or dynamic analysis, carry out code reviews, then establish a process for handling vulnerabilities. In spite of all this, but still after it goes to the production, there can be a kind of vulnerability. So this has to be taken care. Along with this, now let me throw some light, some next 5 minutes or so, with respect to the software supply chain risk. Now, you would have seen when we are building the applications in the recent times, we are no more writing everything on our own. We make use of some open source frameworks, low code no code frameworks, or third party libraries, open source dependencies. Lot of things we are trying to use, and then trying to build our software. Okay, reusability is one of the important thing, and trying to reduce the effort involved in the writing the code. something like semi development outcome comes, that from there you try to fill the remaining things and complete the software development. And when you are doing this, okay, you are using so various development tools, misconfigurations, okay, third party components. See, when you are depending on other things, there itself there can be some kind of vulnerabilities which can be part of your software also. Like for example, the Java, the logging mechanism, logging library had got vulnerability. Because of that particular thing, what happened is that, so adversary could try to inject. See, now log will be collected in the in the environment where you have hosted that application. Java logging library is there, okay, and you hosted in a particular thing. Through that vulnerability in that logging library, what happened is that adversary is able to inject malicious code through the log, which has to be executed in that environment, in that organization. Okay, through the log, the malware could be injected. Similarly, there are cases, I think, through struts framework and all, there was a vulnerability, the application which was developed with the struts framework. So through that particular vulnerability, the almost millions of the records are compromised. The database, they could pull it. So like that, see, you might be thinking third party components, they are all good. You need to make sure that they are latest, and any known vulnerabilities are fixed by those kind of things are very very important. Okay, so supply chain risk, in the sense, you are not doing everything, you are trying to depend on other people, and in that particular chain, the supply coming from the various, there can be some vulnerabilities. Because of that, that system can be compromised. Okay, build environment, CI/CD pipeline, okay, public repositories. See, public repositories also, if there is no access control properly, git repository and all, what happen, people may try to inject something there. They may try to steal some the keys and other things like that. Lot of things can happen. So software supply chain security is the practice of protecting every aspect of software development and delivery process. These things also need to be very very important. Okay, so the prominent risk in the supply chain are, it can be from the development tools, build approach, build systems, CI/CD pipelines. Okay, so these can be compromised by the attackers. See, in one of the software, SolarWind, this company, what happened is that the patch management system got compromised. Okay, so when the patch update was supposed to be given to all the installations or deployments, the malware got installed in all those organizations. So it's very very important that you try to have a secure channel even for the patch management also. And then whatever custom code which is we've written internally might not have worried about putting security practices, though you have built that particular thing. And off the shelf software solutions which you try to take it might be having some exploitable flaws, and third party open source libraries like that. So these are other channels which can have vulnerabilities, and it can infect the systems. Okay, so there are various things: unpatched open source libraries, outdated dependencies. So, see, many times what happened is, though some specific versions, people say that you are not supposed to use them, because, like, you can go for later versions where the vulnerabilities are fixed. People still continue with the outdated dependencies. Code can be tampered, secrets can be exposed, and public repositories, if the proper access controls are not there, changes can be done and malicious code can be injected. Dependency confusion and typo squatting is a case. Package names, whatever we use it. So for popular package names, they try to mimic and try to insert malicious package, the code through that particular thing. Okay, compromise build infrastructure, insufficient software bill of material management. So if you don't have complete visibility of all the various components of the software, of your software, then again that is a problem. And the source code leakage, these are all the general risks which can exist. So it's very important that prioritize visibility and security across the entire software. We should have complete picture. So even if you have open source things, you should know the security testing done through those components also. Okay, you have to, it is your responsibility. If you are bringing some third party component, okay, in your system, then it is your responsibility to test the security of that. It is not the code which you have written on your own. All components which are integrated, you should have visibility, and the complete security assessment has to be done. Security shared responsibility of team, adopt software bill of material practices. So whatever the components, each and everything, you should have a picture, and then you should have a security. Ensure CI/CD pipeline security. Okay, build approach ka, implement thorough access control, and then automate policy enforcement, not the manual. Conduct regular security audit assessment. Use proactive and continuous vulnerability scan. Train project teams on secure practices. Okay, so that is all about this. So what I tried to communicate in the last 1 hour 10 minutes or so is that cybersecurity, though there are various domains, one of the most important thing is the people who are writing the code. Writing the vulnerability free code is very very important. Okay, for that, how do you do that? It is not just a vulnerable functions or anything. We should start thinking about the security from the requirements gathering itself. Okay, if I am asked to build some web application, okay, I need to think about it after it goes to the production, how my system can be abused or how my system can be exploited. Okay, think from an attacker perspective. Then accordingly you try to identify the security requirements and enable them, design them. Then testing phase, okay, thoroughly static analysis, dynamic analysis, we use the word SAST, DAST and all, and secure coding guidelines, like that. All these things have to be done. At the same time, now in the recent times, we are no more trying to write every line of code of the software which we are trying to deploy. We are depending on various third parties. Okay, okay, so open source libraries. So it is very very important that you take care of those things, because they implicitly they may try to bring vulnerabilities which may impact the software which you are doing it. Okay, all these things are very very important. So and this is something, this area is to be known by everyone. It is not just restricted to only, okay, I want to pursue cybersecurity, though I only such people need to look into that. It's not like that. Anyone writing the code, if they have the knowledge in this particular domain and practical exposure, definitely they are valued in the industry and everywhere. Okay, so just I will try to touch upon four questions, and then we will try to go to the some question and answer sessions. So code red worm spread by exploiting which vulnerability? So it is a buffer overflow, right? Hope you understood. Okay, it has exploited buffer overflow vulnerability which was left out in the IS web server. The objective of adversary is to what? What the adversary is normally doing, whether he enhances the performance of information system. Adversary is the crook or the person with the malicious intention. He will never think about enhancing the performance. Okay, cause the undesired or malicious behavior. Exactly. So his objective is to carry out some kind of malicious activity, right? So, third question, which one of the following precisely defines software vulnerability? How do you distinguish a vulnerability and a bug or something? Any software flaw is called as a vulnerability? No. Oh, it is something bad that can happen in the business sense? No. Okay, it might be, but the precise or comprehensive response is, it is a software flaw, but that can leave open for violating the security policy, which can be confidentiality, integrity and availability can be violated through the vulnerability. Okay, so that is the response. And subset of these flaws or bugs are nothing but the vulnerabilities. Okay, and misuse cases help us to represent what why in a secure SDLC, why do you go for misuse cases? Malicious behavior. So normal behavior we try to do with the use case diagram, okay, while gathering the requirements. But when you want to have a robust and resilient system which you are trying to build, you also need to think like an attacker, try to think what kind of risk can exist in my system, and try to understand the abnormal or malicious behavior. Okay, so that is called misuse case. Accordingly, you try to build the security functionality in the system. Which one of the following is more appropriate? So, secure software development lifecycle is a proactive approach to address cybersecurity threats. Yes, this is the right answer, right? So, firewalls and other things, they all only do the reactive approach. When something is penetrating, they try to block. Okay, but the secure software development lifecycle approach is to keep the vulnerabilities to the minimum. Okay, try to avoid the vulnerabilities. So, it is a proactive approach to address the cybersecurity threats. Firewall and all, what they do, if something is penetrating through the vulnerability, they will try to stop. But secure SDLC will try to stop the vulnerabilities itself, remove the vulnerabilities. Okay, these are some references which we will try to share it with you.
So my topic will be secure code review using the practical tools SAST and DAST. Here, what is the main aim of secure code review is, once we are developing the application, as a developer or as a tester, we need to focus on vulnerabilities. Our main aim is here is to focus on the vulnerabilities, how we are overcoming with the different vulnerabilities, how we are reducing the number of vulnerabilities that are existing in our application. So in order to overcome this all, we will use some of the tools that are automated, which will give the list of vulnerabilities. So using SAST and DAST, SAST is nothing but static application security testing, and DAST is nothing but dynamic application security testing. So these are some of the automated code tools which will help the developer or the tester to perform the secure code reviews. So we will see our this topic agenda will be importance. We will see what is the importance of the code review and what is the necessity of code reviews, with some of the examples which I have captured from different type of vulnerabilities, and what are the different types of code review processes are existing. We will introduce some of the SAST. I'll give small introduction about what is the SAST and what is DAST, and we'll also have a practical exposure to some of the tools like CPP check, SonarQube, which are SAST tools. As a developer, when we develop the code, we will experience a vulnerability, right? Manually, we cannot see all the vulnerabilities, and we cannot go line by line and check whether our code is having the vulnerabilities or not. We have to give some of the jobs to the already existing tools. They will scan our files, our project files. They will give the list of vulnerabilities as soon as you write the code in the IDE. So there are different tools available. So right now I will be discussing about the CPP check and the SonarQube. And we also have the DAST tools. The SAST will focus on only the when we write the code, when we develop the code in the IDE. But when we run the code also, we will experience some of the vulnerabilities. For that also, we have existing the tools available, like for standalone applications, we have Valgrind, which is used for CPP check, and we also have many tools like OVAP, Zap, and many other tools which we can use as a DAST testing. And I'll give a small demo on SAST and DAST. So let us discuss about each topic in detail. So why it is important to perform the code review? Because it is very important, because it will help us to identify the bugs, vulnerabilities, issues early during the development itself. Rather than going into the testing and the cost of it may become the cost effective. Instead, what we are following is that we are following a shift left approach, which will help the developer to improve the code quality, not only in terms of security but also in terms of functionality. So it will improve our code quality. It will reduce the number of security vulnerabilities, and it also encourages in the collaboration, and it also used for the knowledge sharing. The most important is that it will reduce the cost of fixing the vulnerabilities later in the during the testing phase. So later during the development itself, if we will identify the vulnerabilities and we will reduce it, then during the testing phase, it will reduce all the vulnerabilities to some extent, so that it makes the job of a developer and the tester easier. So let me give one example. This is a small example which I have taken from the chat GPT. So I have we have to make be sure that if we give any prompt to the chat GPT, it should be very clear. It will understand that it will understand the prompt you have given, and it will give the solution for that. Okay. So based on that, I have taken a small example. The example here is, I have given a prompt that give me a quick C++ program to read the user input. So what AI generated? It has generated some code. Syntactically, it is correct. But when it lead to the security, it is a potentially unsafe function, because here the array we have declared an array. They have given a program that is character of 5 bytes. So this array will hold only the 5 bytes array. It is a 5 bytes array where it can hold you up to 4 characters, and the last one will be the null terminator. But we are directly reading the input without doing any kind of validation here. So the prompt which you have given here is that C++ program to read the user input. It has given me the program. But whenever you ask it to give the safe function, it will give you the safer function with security added to it. Let me show practically how it works. So I have opened the ChatGPT. As a whatever prompt which we are giving, it will be given to that. I'll ask a C++ program to read the input. Okay, it has given me some program. See, same program, anything. It is reading the. So it will give some program here. It is directly asking to. It is directly reading the input from the user before checking the validation. Before applying the validation, it is directly giving the input. So what happens if I run the same program here? I'll open the online compiler. And what I'll do is, this is a program which I have, which was generated by the chat GPT. So I'll just paste it and run it. See, my character array should hold how many characters here? 5 characters. But first I'll give more than 5 characters. Let us see what happens. It has been executed, but something is given as an alert, that is stack smashing detected. That is nothing but buffer overflow. The capacity it can hold is up to 5 bytes. But what you are trying to do, you are trying to load it with more characters that it can hold. So the stack smashing has been detected and it has been overloaded. So here in this way, these type of prompts, whenever we are giving to the AI tools, we should see whether the prompt which we are giving is correct or not. Based on the prompt given, it will give the output to us. So this can be fixed by the safer function, that is seen get name. This safer function, what it does is, it will only read only 5 bytes of array and the remaining will be ignored by the compiler. Clear? So what are the basic side effects of, you have to use AI. I'm not saying that you have to not use AI. You have to use it, but based on the prompt which you are giving, you have to restrict it. That this prompt which you are giving should be clear, that it should give a clear solution. After getting the solution, you should not directly implement it. You have to examine it whether it is giving the correct output or not. Clear? Uh, Okay, that was about a small example I have given, scenario where we will use it. Nowadays we are using AI tools for uh, like how we are, sorry. We are using AI tools in order to generate the code, and many issues have been coming by directly copying the code, and there are many security flaws which had to be identified. We have to see the safer alternatives instead of using the unsafe functions. So here the unsafe function is C in name. Here directly we are taking the input and we are directly printing it. So instead of that, we have to validate it. Validate it is nothing but we have to check whether it is of 5 bytes or not. If it is 5 bytes, then only accept the input. Clear? So what are the side effects of using AI means, we have to be, the code which was generated may be syntactically correct, but it is unsafe, as you have seen the example as well. So blindly we have to we have to not use the AI generated codes, because it may understand whatever prompt you have given. It will give the solution for that itself. It will not think in the inner manner whether it is security free from vulnerabilities. So it will not think all such scenarios. So based on the scenario which you have given, it will give the output. So we have to be clear. Yes, exactly. That is the exact point which I am trying to convey to you. That is, we have to convey the AI in such a way that it should understand our prompt and it will give our solution. So if we are giving a different prompt, it will give a different solution. So whenever you are using the LLM tools, make sure that you are using it, you use for it for their understanding, not for implementation. you can use it for implementation, but directly don't implement it. You first examine it whether it is correct or not, then only go for actual implementation. So this is a another example. I think I have not discussed. Because Lakshmi ma'am have already discussed about the buffer overflow. What is its impact on different types of scenarios, real world scenarios. Also, she has explained everything. So here is the basic example I have given. So in this example, what happened is I have taken a same scenario. I have taken this program from the Chat GPT. That I have asked that I want a program where I have to copy the buffer from one buffer to another buffer. So it has given me some program, but I didn't ask it to generate a secure free code. I just given a prompt that I want to copy one destination buffer to the source buffer. So it has given me some kind of example with where here, if you see, I have a function unsafe copy here. So these unsafe function copy, it has a character byte of 5 byte of arrays. It has been following a function. Here the predefined function is there, strcpy. Remember one thing, that strcpy is a unsafe function which will not perform any kind of bound checking, because when we copy this buffer into the input, it will not perform any kind of buffer input validation. It will not do any kind of validation kind of is. It directly copy the buffer whatever the user gives the input. Let us see the execution of it, like how it has given. In the normal scenario, I have given the input as a 5 bytes. In the normal stack, as we all know, it will consist of 3 blocks of memory. The first block of memory will be 5 bytes of array, because we have declared the array of 5 bytes. And the next byte will be the save base pointer address. It will consist of 4 bytes, and it is the address which I have given. Then the last block will consist of the address to the main, which is of 4 bytes. So this is a normal scenario. But what if a attacker who is trying to exploit, he will have, in order to get access to the shell code, he may give some other input, because we are not following any kind of validation here, right? So he will give the input as a 5 bytes. Here we are not doing any kind of validation. So what happens? This 11 bytes of array, how it gets divided is that first 5 bytes will be allocated here. See, because we have declared a character array of only 5 bytes, right? So this 5 byte, it can hold only 5 bytes. The remaining 5 bytes will be shifted. I request everyone to be on mute, please. Save voice address. I request everyone to be on mute. So the save voice address pointer, so which will consist of a previous address, the address will be shifted to the next one. Then the address will be shifting to the next block. What happens here is the attacker will get an access to the shell code, where as a privileged user, this privileged user will get all the shell code that is related to our administrator. So the best solution here is that we have to follow certain validation kind of techniques. Then we have another scenario. Request every Meera, Asmita, please be on mute.
பிரியதர்ஷினி இருக்கா பேசாம புக்கு கொடுத்துடுறியா? அவளே போட்டுட்டோம்.
Okay. Then we have another scenario, same scenario, like so I have muted her. Okay. So here in memory we have another scenario. Whenever we have discussed about the different unmanaged code like CPP, here we have the most common security vulnerabilities like memory leaks and the buffer overflow. So what is this memory leak? The memory leaks is nothing but whenever we are declaring a pointer, the pointer will that pointer will be given some block of memory in the heap, and that should be freed as soon as it goes out of the scope. So here in this program, I have asked the ChatGPT to create a variable, to create a pointer, and to give a value without a memory, with a memory leak. So it has given me, this is a genuine solution which I have asked it. I have asked it for a pointer to the chat pointer, which will hold an address of by 42 bytes of integer values, and I declared an integer of 42. Here, this pointer, as you see here, I have allocated the memory here, integer pointer, and I have created it. But after using it, my job is to delete it, because I have to free the memory. Unless and until you free the memory, the heap will be go on increasing and increasing and increasing. So once you free it only, then only the remaining program executions will be running in a smoother manner. Otherwise, there may be some undefined situations where our program may be crashing immediately. So in order to overcome this kind of issues, what we have to do is we have to follow the safer functions. The safer alternatives which we have to use is the unique pointers, as well as whenever we declare a pointer, we have to make sure that we are deleting it. So here I have in this execution, we have a function here, memory. Here the stack will be created for the local pointers. This local pointer PTR will go out of the scope whenever it comes out of the function. But here we are declaring it as a pointer. So in the heap, it will be allocated 42 into 4, that is integer will hold 4 bytes of memory. So this memory will be stored in the on the heap. So this that will be copying on increasing whenever you call that function, because there is no delete function here. So the end call, so return 0 whenever it will be never reached, because we are not freeing any kind of memory here. So in to avoid this kind of situations, what we have to do is we have to use the smart pointers. Smart pointers are nothing but the pointers where the scope will be where the pointer will automatically freed when they come out of the scope. We have different kind of smart pointers like unique pointer, weak pointer, share pointer. They have their own functionalities, but we will discuss more in the upcoming sessions. So this unique pointer, shared pointer, and the weak pointer, these pointer, what they will do, they will in the C++11, after the C++11 versions, they have included this smart pointers. They will automatically free the memory whenever the pointer goes out of the scope. So suppose if we have declared a smart pointer here, integer smart pointer new into 42, then if this pointer will be going out of the scope whenever it reaches this block of memory. So this is about the memory leaks. So why do we require the code review? Is it necessary? You may ask me why code review is necessary. Because I am writing the code syntactically, it is correct. Why I have to go with the security, whether it is generating the security free or not? Why I have to see all these kind of issues? Yes, it is necessary, because instead, as we are seeing the secure SDLC, where security is incorporated in every stage of secure software development lifecycle, right from the beginning requirement to the deployment, we have to incorporate security, as we are seeing number of security breaches which are resulting in present day life. The main reason is that the mistakes, small mistake which we are doing in a hurry burry to in order to deploy the project as a form of sprint. It can be in the form of sprint, or it can be deploying a product in a client. So we are in a hurry and we are not focusing on kind of security vulnerabilities. If we focus on them, what kind of vulnerabilities may exist in our is that there may be the hard coded credentials which we will which will be giving in our code. For example, if you see here, I have given a string of a password. I have hard coded it in my code, and I'm trying to log in with the same username and password. So what it happens is that if an attacker get access to our code, he may get access to the as a privileged user, and he will do all the malicious activities whatever he can do, and he may extract all the sensitive information which is necessary, and he may exploit our system. So in order to avoid that, what we have to do is we have to not use the hard coded passwords. Instead, we have to prefer the environmental variables in order to fetch the secrets. The secrets are nothing but the secure, like it can be the sensitive information which should not be exposed with anybody, like our username, passwords, hard-coded credentials, API secrets, and database credentials. So all this comes under the secrets. So we have to see whether we are following the security safer functions or not. If we are not following the security safer functions, what is the first risk which we will explain? All our data will be exposed to the attacker. So instead, to avoid all this, we have to follow the certain coding standards which will help us to prevent our application from the security breaches. And buffer overflow and memory leaks in C++. And as we have seen in the previous example, I will also show with the help of SAST and DAST tool as well. See, we have different types of code reviews available. The first one is manual review. That is, manually we have to review by using some different coding standards which are available. We have different coding standards like SCI coding standard. We have MISRA C coding standards. We have CWE common weakness enumeration. So we have numerous number of coding standards. By using that, our team will be performing the manual review, and we also have automated testing reviews, that is by using the tools, that is SAST and DAST. The most important thing is that this static application security testing will focus whenever the application, as a developer, what I'm doing, I'm developing an applications. If you see here, this is an example where I have given, I'm writing the code. Immediately it will show me that there is some stack smashing in your code. That means that it is warning you that is a risk in your application. You have to modify it, you have to mitigate it. It will also suggest you the mitigation plan. Mitigation plan is nothing but how to implement this, how in order to overcome the vulnerability identified, what kind of countermeasures you are implementing in that. So it will suggest you the different countermeasures where you have to go back to your code. It also gives you with the line number as well. Directly we can go to that line and implement the mitigate the vulnerability identified. So let us see what are these static and dynamic application security testing. So static application security testing, it is similar to the white box testing. White box testing is nothing but where the tester who is performing the testing, he should have some knowledge about the internal structure of the code and how the code is uh, development implementation is carried out. So it is similar, but here we have a security add-on. Here it will focus on the security vulnerabilities. It will analyze all your source code. You need not execute the code or you not execute the program here. As soon as you develop the code in the IDE, it will help the developer to identify the vulnerabilities. It will scan all the files in your project. Each and every line will be scanned by, if you are incorporating this SAST tool in your IDE. So for example, like it will detect the hard-coded credentials. It will detect the unsafe functions. It will detect the OWASP top 10 vulnerabilities. Every vulnerability can be detected by using the SAST tool. What is the DAST? What type of testing it performs? The DAST will perform dynamic application. When we run our applications, then it will detect the type of vulnerabilities. It will scan. It will apply all the malicious payload to our application when it is running. Sometimes when we run our application, also we may face some vulnerabilities like SQL injections we have, and we have when we give a test our login forms, and it may be leading to the brute force attacks, SQL injection type of attacks. So what this DAST tool will do is, this DAST tool will simulate the real world attacks. Like it will perform the first testing, penetration testing, vulnerability, VAPT testing. So here it will gather all the malicious payloads, and it will give as an input to our running application, where it will detect that there are this many vulnerabilities in our application, and it will also assign the priority level, that high, medium, low. Based on the priority level assigned, it will also that is the risk assessment. It will do the risk assessment based on the priority level assigned. High priority level identified vulnerability should be mitigated first, as they will pose more security on our application. So this is about the DAST. we have different types of SAST tools available. Not only CPP check, SonarCube, we have numerous number of SAST tool available. But whereas when we are seeing with the C++ code, the SAST tool I recommend is that CPP check and also not as a SonarCube IDE. If you are using the Visual Studio Code or you are using the Eclipse IDE, you can go with the CPP check and the SonarCube IDE, which they both are open source, because they will scan our files which we are developing. It will identify all the vulnerabilities, and code smells are nothing but how many lines of code are we following the code quality, as are we doing the implementation with the standards or not. So all this will be detected by using these SAST tools. We can incorporate them into our IDE. So one more add-on feature of this SAST tool is that it can be easily integrated with the CI/CD pipelines as well. We have different types of CI/CD pipelines like GitLab, Jenkins. So it can be integrated with this pipelines as well. So this is about the SAST tools, and we will discuss about the Valgrind in the DAST tool. And we also have a OWASP ZAP. This is used for web applications. So that Valgrind is a tool. It is a command line tool. It will detect the memory related management issues. So it is kind of a DAST tool for CPP applications. And OWASP ZAP, it is used for the web application penetration testing. It is used for running web application. It is used when we are testing the running web application. So this ZAP tool will automatically generate different types of payload, malicious payload, and it is try to inject into our application and test our application how it is responding to the malicious payloads. Then these two tools, DAST tool, any type of DAST tool, what they will do, they will perform all the related vulnerabilities by giving the malicious payloads, and it will detect what is the issue, and it also suggests you the mitigation plan, how you have to overcome such vulnerabilities. So these are the different DAST tools. So let me give one overview of it. Like, you have a source code with you. Like, it can be of any language. Like, it can be in any language you have developed. What you will do, you will develop the language in an IDE, right? In that IDE, you have to incorporate a SAST tool, that is as a plugin. I'll show you how to incorporate it. As a plugin, you will incorporate that SAST tool. What this SAST tool will do is, it will scan all the files in your project. It will identify all the vulnerabilities, as this SonarLint will have some predefined rules in it. So for a language which we have developed, in which we are developing, this SonarLint or any kind of SAST tool will support multiple programming languages. It has some predefined rules in it. These predefined rules will be applied to your application. It will scan it, and it will give you the list of vulnerabilities with the mitigation plan, or redirecting any reference that will help you to mitigate the application. So this is how you integrate a SAST in your IDE. Then so for DAST, you require a running application, and it will simulate the attacks on the application. Like whenever, like it can be on any kind of attacks, it will simulate the attacks. Here you manually you are doing nothing. It will only create a simulation attacks. When you give the URL or when you give the exe specified to the tool, it will cover all the vulnerabilities, and it helps to uncover vulnerabilities by which are missed by the static analysis. Previously, we have found some vulnerabilities. We have mitigated it. But whenever we run the application also, we may experience some vulnerabilities. So that can be rectified, and that can be mitigated by using the DAST testing. For example, the testing the input fields in the login form, and buffer overflow kind of issues, and memory leaks kind of issues, SQL injection kind of issues. It can be any kind of vulnerabilities. It can be detected by using the DAST testing. So this is a practical tool where SAST is used for source code analyzer. It will give you one vulnerability report, and it is done during the development phase. Then it is a DAST is done it is done on the live application. It is during the production phase and the release phase. So we have seen some SAST DAST tools, right? But how this SAST to DAST tools will know about the vulnerabilities? because they will know about the vulnerabilities, as these SAST tools will be incorporated with some of the security coding guidelines. These coding guidelines are nothing but we have different coding guidelines in our session. These are common weakness enumeration. These common weakness enumeration is a community developed list of common software weaknesses. It is managed by Mitre, and it will give you all the IDs. It is specified by the particular ID, which will give you the vulnerability list. What does this vulnerability arise from? What are the mitigation plan we have to include it? What type of what type of impose it may pose on an application, and it will give you the complete software weaknesses. And we also have a cert coding standard, not only for C++, we have coding standard for JavaScript, Python, and as well as different programming languages. So it is published by the Carnegie certain universities. So these will give you the coding standard specifically because I'm talking specifically for C++. So it will give you the different coding standards, as they have designed some rules. That rule format will be like, there will be an identifier. That identifier will give you the risk level. So based on the risk level identified, you will mitigate the vulnerabilities. Then we also have an automotive industry coding guidelines, that is MISRA, which stand for Motor Industry Software Reliability Association. This will also aim to define the secure coding guidelines, which will be relying on the safety. So these are the different secure coding guidelines. They are internally mapped to the SAST. By using these coding guidelines, the SAST will trigger you. There are certain vulnerabilities in your applications. You need to mitigate it. So how the workflow will be like when you incorporate SAST is that, this is a start process. There will be multiple developers working for the single project. So I will be incorporating the sonar lint, and the developer 2 will be incorporating the sonar lint. But whereas the developer 3, he has not incorporated the sonar lint. So what happens? The repository which will be indirectly given can be taken from the GitLab, and where even though this developer is not integrated the sonar lint as a plugin, this can be finally generated, finally visible by cloning this repository, because they are using the CI/CD pipeline in order to get the vulnerability list. Finally, it can be integrated to the centralized server, that is SonarCube. It will give you the dashboard, which will generate a report, and it will perform all the analysis whichever the developer is performing. Because the developer 3 will also commit the code into the repository, so that will be deflected into the repository, that will be finally given to the SonarCube. That SonarCube will perform the analysis, and it will generate and send report as a vulnerability report, which is used for us to come out of different mitigations and vulnerabilities identified. So let us see about different practical tools for security. We have CPP check, Valgrind. So this CPP check is a static tool which will detect the vulnerabilities during the development. Valgrind is during the runtime. Like, it will deal with the memory kind of issues. It is also used for the memory leak detection, and it is used during the runtime. So let me show you a demo on this. Is my screen visible? Okay. So here, one second. I am using the IDE as a Visual Studio Code. Here, I have a small code here, the vulnerable code. First of all, when you want to install a plugin, you have to go to the extensions and you have to install the SonarQube plugin. So I have already installed it. For me, it will detect the vulnerabilities. So for example, let me show you. See, here I have already integrated the CPP check in my application in my Visual Studio Code. I will try to run the analysis. For that, so you have to go to the extension and you have to install the Sonar Cube and the CPP check. Anything you want to install, here you can install. I have installed the CPP check. So here I will try to run it. So first one, I'm not doing any different modifications here. I'm just trying to remove my comment. So what it is doing, if you see down, it is performing some scanning testing. It is analyzing. So it will analyze and give the report in the problems pane here. Like what type of issues are there with respect to your file. If you want to see the report, click on it. Then you can again rerun it. See, code analysis model, you can run it. It will ask you on which file you have to run. I am running on the current active file. So it will display with a blue colored curve line. This yellow colored curve line down with a bulb icon here. This bulb icon, it says is that there is a vulnerability in your program. So if you want to see that, just hover on it, or you can go to the problems pane in the down. It will give you that string copy is insecure and it does not provide bounding of the memory buffer. So you can replace it with the mitigation plan suggested by that. It has suggested some mitigation plan. You can directly go there and see what type of mitigation plan it has suggested. So this is a kind of mitigation plan it has been suggested. So for each and every program, previously I have run the scan for complete project. So it is giving me different kind of vulnerabilities like, see, call to string copy, and I have a dangling pointer as well. What is this dangling pointer? This dangling pointer is nothing but we are trying to use a memory that has been already freed. So here what happens is that I have declared a pointer, I have deleted it, but I'm trying to use the same pointer which has no memory address pointing to that pointer. So what it is suggesting is that you are trying to use the memory after it is freed. So yellow color indication is nothing but there is a vulnerability in your file. So you need to overcome it by using the mitigation plan suggested by it. So this CPP check also comes with the command line tool. So I'll show you. So I have a function buffer overflow.cpp. This buffer overflow.cpp, what this function is doing is that it is doing some unsafe copy here. Like it is following the unsafe function where if you see here the yellow color line is there in our IDE means that there is a vulnerability. It can be high priority or low priority. There is a vulnerability. So what we have to do, we have to mitigate it. You can see by hovering on it, or you can go to the problems pane and you can see the list of vulnerabilities it will be giving, or else it will display down that warnings are 10. There are 10 warnings, that nothing but 10 vulnerabilities in your application. Why it is has been categorized as warning? Because your program will be executing normally, because there is syntactically the program is correct, but there is a security warning in your application that there is a vulnerability. So how it can be done by using a CPP check is that when I run the program buffer overflow.cpp, it will be running normally without any issues. So it has been run and I will execute with the executable file. See what happened. It is telling that stack smashing has been detected, because here I am giving the capacity that it can hold is 10, but I am giving the memory string more than 10 bytes. So how it can be checked is that by using CPP check, as I have shown in the GUI interface. Now I will show the UI command line interface where you will be detecting it. For that, we have a CPP check command. This CPP check command you have to execute with a file name. What is this file name? Buffer overflow.cpp. So I will hit enter on it. So it is suggesting me that the buffer is accessed out of the bounds. You please, and it is giving you the line number as well. Where is the error actually? Where is the vulnerability? So this stack smashing has been detected on the line number 612 and in the function string copy buffer input. So using CPP check, you can detect the vulnerabilities either by the UI interface or by the command line interface. The command line interface will also give you the different types of vulnerabilities as well. This is about the CPP check, the SAST tool. But what about the DAST tool? The DAST, we also have a DAST tool, right? Valgrind. This Valgrind tool, what it will do when it will identify the memory kind of issues. What kind of memory? So I forgot to tell you how it can be mitigated. So I'll show you that one as well. So buffer overflow, I have shown you how the unsafe function, but you have to see the safer function as well. See, I am using here string and copy, which is a safer alternative of using the string copy because it is doing the validation here. It is buffer. It is checking for the buffer size and it is taking the value of the null terminator. It is ignoring the null terminator and taking the value of up to and limiting it to the size of the buffer. So the safer alternative which we have to use is that string and copy because it will ensure the null termination and it will prevent from the excess buffer overflow kind of issues. So the safer alternatives, we have to always choose the safer alternatives which will perform the bound checkings and which will do the input validations. So it will be preventing our applications from the multiple malicious activities or the malicious users who are trying to exploit our system. So next one is we have different kind of vulnerabilities like race conditions, deadlocks, and we have different in the race conditions. If we are not properly using the synchronization mechanisms, with it can lead to the undefined behavior where our program will be going into some different state and input will be and our application will be in the hands of an attacker. So how it can be done by using some synchronization mechanisms by following the mutex kind of issue functions which will prevent our applications from the race conditions. So I'll show you the memory leak kind of issues. Sorry. So this memory leaks, if you see this function, here I have declared a integer pointer leak and that I have allocated 100 as an array of 100 bytes of integer type. This integer type I have declared it. I have trying to print something, but I have not freed the memory and it is running in the while loop. So what happens if you execute it? It will be continuously leaking to the memory leak. So here it has been given me that value stored to leak. If you see the here yellow color line has been indicated and it is telling that value stored to leak during its installation is never read because it is installation has been done and it is leading to the memory leak kind of issues. So how it can be mitigated, I'll show you because it will be detected only during the runtime. First I have to run the application. I'll compile it. I have run it. See, it is continuously running and at some point the program will be crashed. So in order to avoid this kind of issues, what we can do is we have to run our program predefinedly. We have to directly use the Valgrind into our application, which will detect this kind of vulnerabilities. Now, what I am trying to do is I am trying to incorporate the DAST tool Valgrind just before I have just given the exe file. Instead of that, what I am doing now is I am trying to run the application with this exe file. So Valgrind memory leak. So this Valgrind is a DST tool and it is now I'm trying to identify any kind of memory leaks and I'm trying to perform the check on full project. So I have to give my exe. So if I run it, see, it is performing the scanning to in my file and it is seeing what kind of print, as I have given the cout statement, so it is giving it. Finally, when you stop the program, it will give you the memory allocated, like what is the heap summary and what is the leak summary. As we have already seen in the UI interface, that is, there is a leak summary in our project, right? So what is that leak summary? If you see here, it has given you the heap summary here. We have allocated some 3,844 allocations has been done, but it has not been freed. So one this 1,06,69328 bytes have been allocated. I have stopped in the middle. Otherwise, it would be running up to half an hour and the project will be crashed. So in such kind of situations, if you are unable to figure out where the exact issue is, you can use this DAST tool. It will give you, if I am running in this on a single file, you can also run it for the multiple exe files as well, which will give you the leak summary. That here, if definitely lost is that it is the memory which is still in use. It has not been freed. This definitely lost will indicate the memory which is still in use, but it is not been deallocated. And still reachable, this still reachable will give you the memory that has still to be allocated. So we have not deallocate the memory. The memory will be go on increasing in the heap, and at a particular time our program will go into some different behavior and the program may crash as well. So we have to make sure that we are incorporating the safer alternatives in our function. So how it can be mitigated? We can mitigate it by using it will also suggest you the mitigation plan. The mitigation plan suggested here is, if you click on it, it will give you the mitigation plan that I have implemented here. The mitigation it suggested is mitigation plan suggested. It has suggested me to use the unique smart pointers. So this smart pointers, if I run, I'll show you with the example as well using the Valgrind only. So this is a program which I have given. So I'm trying to run it. I have stopped it, but I'll try to run with the Valgrind. So here, if you see, I have mitigated it, right? Previously, we have received that there were some allocations, but there was no freed memory. But when I am using the safer alternatives, what this Valgrind tool is suggesting that there are particular allocations. For that particular allocations, you are collectively freeing your memory. So in previous example, we have seen more than 3,000 blocks. Definitely lost bytes. But here we are seeing only one block. That means our program is behaving in an expected manner. There is no kind of leak summary in our project. We can run it smoothly. Clear? So we, as a developer, what is our job is that whenever we write our code, we may not focus on our vulnerabilities. So we will be go on developing the code. In the IDE, we will be writing the code. So I am writing some code now. See, immediately the IDE will automatically trigger and it will perform the analysis. You need not specify that you have performed some change. Immediately you perform some different change in your IDE, it will be triggered by the different SAST tool. See, down you can see a loading symbol. Whenever you do some changes, it will be automatically triggered. So this triggering will be done by the SAST tool. Here it will identify the vulnerabilities and it will detect the vulnerabilities, and that will be shown to you in the problems pane in the editor which has been given. So for that what you have to do is you have to install the CPP check. You have to install the Valgrind tool. So this installation is very easy as it is a command line tool, or it can be integrated with different kind of IDEs. So it will help the programmer automatically detect that kind of vulnerabilities. So whenever you run the application as well. So we also have a sonar cube. That sonar cube, what it does it, this sonar cube, when you integrate it, it will give you all the list of vulnerabilities, like what are the list of vulnerabilities it is having. It will give you the dashboard with the security hotspots as well. And we also have a DASAST. As we have limited time, we cannot focus on all kind of tools. In the course we will be discussing all this kind of tools, and in-depth knowledge we will be giving, like as we have only limited time now, we will be showing how the web application will be handled, how we can overcome these vulnerabilities. All this focus area will be covered in our course. That course will be mainly to the secure software development lifecycle, where we can come out of different vulnerabilities for web application, standalone application. It can be kind of any kind of application, how we can make our application free from different kind of vulnerabilities. So we have to focus on development as well. We have to focus on testing as well. The testing is an important part where the security vulnerabilities will be identified. But in the shift left approach, it is not mandatory that vulnerabilities are different identified only during the testing phase. The vulnerabilities can also be identified during the development phase as well. We can use different kind of SAST tools which will help the developer which will make the developer job easy by identifying the vulnerabilities. That will also give you the risk assessment, because they will be incorporating certain different coding standards in them. That coding standards will be directly incorporated into that SAST tools, which will help us to identify. So this is about the secure code review using SAST and DAST.
Good evening, all. As my colleagues have explained you about the need for secure software development lifecycle practices, now I will move on to the necessity. I will move on to the way how this course will be conducted, and I will probably it will answer all your queries which you have posted just some time back. So this course will be offered in three different modes. One is self-paced, where we have recorded video lectures, and we have LMS portal also, in which once you log in, you can have access to text material, and practice quizzes are also available. Apart from that, you can also attend online programs. Occasionally, we will be conducting online courses, online training also. So whenever it is scheduled, you can register and you can enroll for the online, which is going to be an instructor-led training program. And in case of self-paced, as you are aware, you can access the material anytime. So the course content, actually, it has been developed by senior developers from the e-security department of Center for Development of Advanced Computing, Hyderabad branch, and CSE department from IIT Bhilai. So my colleague, Mr. Dr. Amit, is also, I hope he's attending this particular session. He has already joined, I think. So he will be delivering certain lectures in this one. And the course duration is approximately 40 hours. So this 40 hours comprises both theory and lab. When we say theory, it includes demos, everything. The resource persons will explain you about the theoretical concepts, and which will be followed by a demonstration of various techniques, strategies, and tools, which will be helpful to you in implementing secure software development practices throughout the course. Apart from that, there will be lab assignments. We will be giving you some lab exercises while the course is going on. So you can practice those lab exercises once the core training session is completed. So this course contains around 7 modules. So basically, as you can see here, there are several topics have been included in this particular course, starting from introduction to secure SDLC phases, and then at the time of requirements phase, do we need to bother about security or not? So why we need to look into the security aspects during software requirements phase itself? All these things will be covered. Uh, and then secure design considerations and principles. There are several design considerations, design principles are there. When you develop the software, you need to follow certain secure design principles. So we will be giving you information about what kind of principles you have to follow, how to implement them. All those things will be explained here. When you start developing the software, you need to look into the threat perspective. From the threat perspective, also you need to analyze your software development activity. So how to do attack vector analysis and then threat modeling. So these two are very important aspects in software development because they will let you know what kind of threats can be perceived in your software, and you can prioritize those threats before going to the implementation part. So while prioritizing the threats, you can also mention what kind of mitigation plan the developer has to take into account when he starts implementing the software. So all those aspects will be covered in the design principles. And once the design is completed, uh, your design actually goes to the development team. There, the development team will start working on developing the code. So Swati, sometime back, I think she has already explained you about different IDEs like VS Code, how to use VS Code, how to integrate code review plugins into the VS Code, which will help you while writing your code. That will help you in giving certain hints like whether you are using a safe function or unsafe function, or all those aspects will be covered. And then security testing also, we will give you certain metrics to understand how to keep track of security issues that are opened or that are resolved right from the beginning of requirements phase till the implementation phase. So how to track all these things will be explained in the software testing. So once these 5 steps are completed, as you know, software development is not a one-man activity. Not a one-man activity. Several developers will be working on a single project. Sometimes probably they may be working from different locations, geographical locations. So how do you, I mean, in such case, when the software code has been, when the software code is committed, how do you ensure that the integrated part is not compromised, or integrated part is has been handled properly at respective places? It doesn't contain any security issues. How do you ensure these things? So that is where the continuous integration and continuous development tools like a GitLab will come into picture. When you configure GitLab, developers from different locations, they can commit their code, and when they commit the code instantaneously, certain security tools will be triggered at the back end, which will uh, check whether any known vulnerabilities are still exist in your code or not. So how do we configure all these things? How do you set up the pipeline? How do you build? How do you set up this pipeline of automatic triggering of security vulnerability verification? So all these things will be explained in this particular session. So now I hope you understood like what is that we are going to cover. It is not a very simple job. You will have to go through, it's completely a hands-on course where you will listen to the security, you will listen to the topics from the resources. You have to practice a certain lab exercises, and then you have to submit lab assignment and case study also. Okay, so I'll explain the process here. So first step is obviously you will enroll to the course, and then depending on the mode of depending on your interest, either you can opt for self-paced training or you can opt for online training. whatever may be the mode, whether it is self-paced or online training. As I mentioned, once you go through the material, you will have to submit the lab exercises, lab assignments. So what we are doing here is, we have hosted our own portal, LMS portal, where once you enroll to the course, you will be given user credentials. So you can start accessing the material in the online LMS portal. While going through the content, you can actually practice a certain practice quiz questions also, so that will help you in for your preparation for the certification course. And then once you are comfortable with the course material, everything, then you have to submit lab assignments and case study. These are two different things. You have to submit. We will be giving you around 7 to 8 lab assignments. Out of them, you may have to, you will have to submit around 5 lab assignments to us. Apart from the lab assignments, you also have to submit a case study. So then what is the difference between lab assignment and case study? Lab assignment, actually, they are all small exercises which you need to work upon to see whether you are comfortable in using different tools or not. So then what is about case study? Case study is actually, what we will be doing here is, you may be good at, we know that in software development life cycle we have around 5 to 7 different phases, right? Starting from requirements to the deployment phase. So in whichever phase you are comfortable, in whichever development phase you are comfortable, we will assign you a case study. Case study will contain a problem statement. You need to see how you will address that problem statement in 2 or 3 different development phases, software development phases. So probably if you are if you are interested at the manager level of role kind of thing, then probably you can take requirements phase and design phase. So now you have to submit a report to us stating that how we are going to address the problem statement only with respect to implementation and development design phases. Likewise, some other person may be interested in design and implementation phase. So you take a call. We will give you the problem statement. You let us know how you are going to resolve that particular problem statement with respect to any of the phases in which you have more interest. So that is the way the case study has to be submitted. Once you submit lab assignment and case study, then only you will be given opportunity to appear for the online examination. And online examination is completely video proctored examination. So I hope you are all aware what do we mean by video proctored examination. You will not be allowed to move your you cannot access any other tab or any other file on your system. So it is completely in a secured manner. The examination will be conducted. In case if any candidate tries to uh, take a break or tries to do some kind of mischievous things, immediately the exam will be terminated at that point of time. So this is the model how this is going to be conducted. I already covered all these things. Evaluation process, as I mentioned, you have to submit lab assignment, case study, and certification examination. Certification examination will have around 100 questions, and I can say probably the difficulty level is from medium to high. So here we will be giving 2 types of certificates. One is participation certificate, the other one is professional certificate. So what is the difference? If you complete all the 3 steps, like submission of lab assignment and case study and attending your online examination, then if you get minimum 65% score, then only you will get professional certificate. Otherwise, if you submit only lab assignments and if you do not want to attend for professional certificate, then you can simply submit lab assignment and claim participation certificate. So what is the scoring criteria here? The certification exam, as I already mentioned, it will be conducted for 100 marks, and lab assignments and case study will be evaluated for 50 marks, 25 marks each. But thing is, we will take only 70% of, we'll give only 70% weightage for the certification exam, and 30% weightage will be given to lab assignments and case study. Okay. So altogether, you must get minimum 65% score to get the professional certificate. So this is the exam pattern and scoring mechanism. And in case if physical programs are planned in future, it will be conducted either at C-DAC Hyderabad or IIT Bhilai locations, or otherwise, mostly it will be in the online mode. And the third mode is self-paced learning. So the as of now till October 30th, the course fee is mentioned as 1,000 rupees, and it may be revised very slightly for different types of audience, because this particular certification program is not being conducted only for students, it is being also conducted for working professionals also. So we have different pricing model for different types of audience. For student community, definitely it will be at very nominal rate only. So my suggestion is actually this is very important course. The reason is you probably might be involved in developing your software, but see now if you look at the market, every software has got some economic value associated with it, isn't it? So it is doing a lot of things. So in case if you want to prove that you are very good software developer, uh, in present days, it is very when in case if you say that you know the C programming or C++ programming very well, it alone may not be suffice. You have to write secure coding also, because whatever code that you are going to write, it should not break. It should not become a target for the malicious users, so that they will be able to exploit vulnerabilities in your code and then do different things. So to avoid these kind of things, you need to learn about secure coding practices while developing software. Okay, that is the reason why Ministry of Electronics and Information Technology actually has given us this duty to both SEDAC Hyderabad and IIT Bhilai. So this is going to be very useful thing for the software developers, especially for student community also. So I'll skip all these things because I already mentioned about what are the different topics we are going to learn about. In case of software requirements, there are certain standards and tools are available. We will explain about those standards and tools. In the design considerations, what I mean by design consideration means whenever you design an interface, what kind of precautions you need to take, and how do you go with a programming language selection, and in case if you are going to develop a web server kind of application, how do you secure the communication channel between the client application and the server application? Most of the applications also rely upon database. So what kind of database security you need to be worried about? So all these aspects will be covered here. And when we say design considerations, attack surface evaluation also will come into picture. What do we mean by attack surface evaluation? So you have defined your architecture, your software architecture, some authentication module, which is responsible for logging login information, and database management module, which is responsible for different things like managing the database operations. And there could be multiple modules. So we don't know how the attacker will try to enter into your software, whether through login screen or whether by exploiting any vulnerability in the database, whether he will be able to enter into your system. So all these aspects you need to uh, analyze. That is what we mean by attack surface evaluation. So how to perform this attack surface evaluation, how to prioritize the threats once the analysis is completed, how do you assess your risk, all these aspects will be covered. What we do generally is whenever you develop a software, you are not going to develop everything from the scratch, isn't it? You will be depending on third-party libraries also, right? So how can you be ensure that those third-party libraries are free of software security vulnerabilities? So how do you verify that? That is where we perform software composition analysis. So there are certain tools are available which will help us in knowing whether whatever library we are going to use in our software, whether it is free from vulnerabilities or not. So those things can be analyzed during software composition analysis. So what we did is actually it is not going to be only a theory and few examples kind of thing. It is we are following a learn by doing approach here. So here what we will do is while topics are being explained parallelly, we will make you to work on simple project. So that simple project actually has been developed using programming languages like JavaScript and Python. It is a web server kind of application. So what we will, and it is a project which doesn't contain any security issues addressed in that particular project. So while learning the topics, you have to implement whatever you have learned in that particular sample project and make it robust. So that is the way how this entire program will be driven by resource persons. They will help you in uh, addressing different issues or how to tackle these security issues. All these aspects will be covered while working on these things. So I think Swati has already explained you about what are the good and bad practices. A small example probably she might have given. We'll get into these issues more elaborately during the course time. And we also, I think, you are all aware that um, nowadays people are actually shipping the product, your software product as an image, right? As a Docker image. But when you build your Docker images, those images also may contain certain vulnerabilities. So how do you ensure that your containers, your Docker image containers are secured enough? How do you perform an audit on your security audit on your Docker images so that to understand or to check whether the Docker images contains any vulnerabilities or not and how to address them. Those aspects also will be covered here. And this is the uh, testing environment of our LMS portal. Actually, the production environment has been modified significantly, but it contains the same look and feel. You can access, I think there are around 8 modules, and each module contains a certain practice questions also. This is the way how the LMS portal will look like. You can either submit your assignments, attend practice quizzes, everything here. We will also give you some information about the role of AI in practicing secure coding. So there are expert talks also have been included. So we invited experts from industry, from different organizations like Robert Bosch or Palo Alto Networks or some other organizations like Certin. So this course not only contains the material that has been developed by us, but it also contains a certain expert topics. You can access all the material and give the examination. Thank you. I hope I have cleared all your doubts about the course enrollment and other things.